is nothing new under the sun in terms of software engineering.
Our parents would love to boast about their, oh, you've never known about this technology back in your days.
Even in the faculty, if you want to use computer, you need to fill the form in the lab that I want to use this computer from this hour to this hour.
Yes.
Assalamualaikum warahmatullahi wabarakatuh. Welcome everyone. So today, as you can see here, we're doing something different. So let me introduce yourself first. My name is Alif Marsudia Al-Fati, and today I'm hosting a podcast. It's something that I've never ever done before. And today, of course, I have my friend as the co-host.
My name is Mohammad Moralez. I'm the co-host of this podcast that we're doing together. Thank you, Alif, for the opening. I also have never done a podcast before, so this will be my first ever experience in doing podcasts. So today we're joined by our special guest, Mr. Hafiz. He's one of the development for software development in video. Mr. Hafiz, could you please introduce yourself to our audience?
Yeah, thank you. My name is Hafiz. I work at video.com as a VP of architecture. So it's in engineering department there. And I mostly deal with software matter in video.
By software matter, do you could you please more elaborate on what exactly do you do in video and what aspects of video that we usually use that you've probably managed and created it before?
Yeah, in terms of software matter that I deal in video is mostly on the architecture stuff. So it's kind of like if you deal with house, you need to have architecture, right? Like if you need building that is for certain number of people with like 10 or 100, it will be different structure that we need. So it's kind of like that also in software. So we need to align the architecture with the proper requirement. So if the requirement is for this kind of audience and number of users, we need to design it differently. So it's kind of that method that we need to deal with.
What do you do actually exactly in your job? Do you like a program computer and like coding maybe? So do you have any or how is your experience in coding so far? And what is your exact position in your job?
Yeah. So yes, in terms of coding, I still do coding. So like day to day, if there is a code that needs reviewing or needs some refactoring. So refactoring is term in software development where you change the code to have better design but still have the same feature.
Oh, I see.
So that's mostly the kind of coding that I still do. So if the design is not quite right, we do the refactoring on that. So there's still some coding involved, but then in terms of software architecture that I also do with the team, if is doing the design review, also code review, we need to align various components in the software development so they can fit with the requirement. So there's still coding, but then it's also include with other matter like design review and submitting with other departments, so we can align the needs. Like for example, the product department, if they need this kind of specification, we need to have a meeting with the engineers that relate to it, and we need to come with a middle ground, because sometimes there's conflict with requirement that I want this and I want that from the product or from the management. But then in engineering, we need to also see what is possible and not possible, and need to come up with technical feedback for the business side. So let's just say I want this for our user, for management, but we need to see in engineering, we can do that, but only up to this point, or we need to change some trade-off that can fulfill that, but then we also need to consider the cost. So that's kind of a role that more senior developer or architect that need also to do beside coding.
So it's not only coding, right? Probably coding is like the one part in your job, and mostly it's the combination of other things that you do. So, if I may know, do you have any experience in like teaching students, such as in seminars, maybe?
Yeah. That's also part of the role of being more senior engineers, team lead and stuff. You also need to have some part of the role to do the teaching. So either it's on the team within your organization, but it can also be in the context of professional community. So sometimes professional community have a gathering where people share knowledge and stuff. So that's kind of time to time I need to do also. So doing the talk in the community gathering, like Tech Talk, like in Swift community, in iOS developer community, in some other companies that have some kind of internal seminar there. Like some time ago I did talk in Bukalapak, Tokopedia, and various other moments that developer gather and they share knowledge. There's also occasionally some requests to do some kind of guest lecture in university.
Oh.
Like I did some time ago in University of Indonesia to do some guest lecture there, share the knowledge also with students there, what they could expect in the professional field after they graduate and start to go into the professional fields. So yeah, that comes also with the role. So the longer you stay in the professional field, you also kind of expected to also not to just do your work, but also how to teach others doing the work that needs to be done properly. So usually that comes with experience, so that's why you need to share the experience with others.
So it seems from your story that you've joined many, you've taken many seminars and newcomers to companies, and so it got me thinking that. So I saw in your LinkedIn that you were once a head of OS in BlackBerry Media. Did that was your experience in having had a high position job influence you in any sort of ways?
In terms of influence and insights that I have is probably in terms of diversity. So the more you have more scope in your role, you usually also have scope also with people that interact also larger. So let's just say when you start in your field, you deal with your own team, but then later you will also interact with other departments, other organizations. And in terms of my experience when I did stuff with BBM, BlackBerry Messenger, one of the highlights also how we deal with multinational team. So we need to work with developers in Canada, Vietnam, Singapore, stuff. So that's kind of interesting experience, how we can bridge the differences between diverse countries. But one interesting things in doing things with various people also, that things can be quite different, but in a way they can also be quite the same. I mean, in terms of culture we can be quite different, but then along the way something that connects us, that make that differences easier. Like for example, if we deal with the same professional work, we usually have the same vocabulary in discussing things. If we deal with programs, sometimes we talk about programming first, and then we have that connection, and then we chat and discuss more in terms of the differences that we have in terms of cultural background and stuff. So that's kind of interesting. So if you deal with more diverse variety of themes, you will also see that people have a lot of common things, although they can also have stuff that can be different.
So you have something in common with all those people around the world.
Yeah. Usually, if you do one professional field long enough, usually you have connection with other professional on the same fields. So that's kind of interesting connection there.
It's actually very fun. If you think about it, you have something in common, but you also have some differences in the cultures and stuff. So
I think that could also apply to other subjects in our school, perhaps math. Even though math is taught in every part of the world, it's still math. We can still communicate with each other through the language of math, and etc. etc.
Yeah, on the fun side also, if you are a gamer, for example,
it can apply to
in many other countries they can have different language, but then if you're doing the same game, doing the same stuff, sometimes you have a lot of things in common already. So even if you have something different, you can catch up that part after you have that commonality. So.
I see. Yeah. So I also seen on your LinkedIn that you went to University of Indonesia for your bachelor degree in computer science. So we would love to ask, why did you choose the major of computer science? I think it was quite an uncommon major back in the day when you were still maybe fresh off the bake from the high school.
Back when I started, it's quite a long while ago. Even the technology, like for example emails, it only can be accessed if you are a member of a faculty in university, where you have access to the big computers inside of a very cold laboratoriums there. So it's still in a very early stage of computing field. So there's already some number of professionals in terms of computer, but then the technology itself kind of still used only by either professional or academics in terms of computer science. So it's a very interesting years to start on that field, because when I started there, it's the start of process where technology like computers and internet start to be really mainstream. When I started, email is still very local in academics, but then several years later, you have Gmail, you have Yahoo Mail at that day, and then all of a sudden people are using it everywhere. So it's kind of a year where you have that border between computer being a very specific technology for academics, and on the other side you have just from a very short time it becomes a very widely used technologies. Up to the point that generation that come afterwards doesn't know that before there was no access to that technology.
I can confirm from our experience.
So that's interesting to see.
Our parents would love to boast about you've never known about this technology back in your days.
It comes to the point where at that time that even as a computer science student, even in the faculty, if you want to use computer, you need to fill the form in the lab that I want to use this computer from this hour to this hour.
Yes, you cannot use freely.
Because the access is still limited. If you want to, like you say, if you want to use computer with this kind of specifications, it only have a number of machines there. But at this point, it's kind of virtually any machine that you want to access and experiment on, you can have access right at that minutes at seconds, because even if you have needs to have access to very highly sophisticated supercomputers, you can just access it from the cloud, where the computer is in some server somewhere, and you can just access it remotely.
That was almost impossible 5 years ago.
Yeah.
Now it's suddenly
yeah.
just pop up cloud
Yeah.
gaming on a remote.
You need
And-
to fill the form back then,
Yeah,
and then
no,
you need to
very rapid.
wait for your turn to have access to that computer. Yeah.
So
It's very different days.
so these days you have computers that are more complicated and more sophisticated,
Yeah.
and through the development, there has been a lot of things that has been improved. And what is actually computers back then, before like internet, before other
Yeah.
platforms are being developed?
Yeah, that's what interesting about computer field. You have a very different devices today. Like for example, you have this phone.
Yeah.
You have a TV.
Yeah.
You have even watch. You have even a car, where all of them have computers. So the form can be really different, but then if you compare it with what exists back then, and you study the concept as a, let's just say, computer science student, you will find that behind the scene all of them is very much the same. So if you study computer from the conceptual level, they just basically just the same operation that being done only on different casing, in
Yeah.
terms of what happened underneath is quite the same. So that's why one of the saying in computer field, some say that there is nothing new under the sun in terms of software engineering, because sometimes what you see, even like you say in software development, just for example, like you say, they have these new people using, like you say, like multiple program run out at the same time using this, they say, they call it like coroutine or functional programming, that people do that stuff now, that they see, oh, this is the most optimal solutions. It actually, if you see that that technique is being developed like in the early days, like 70s and 80s, that's pretty much the same way they're doing it now. So people find that when they first learning, wow, this is new, this is optimal, this is better, it actually already being used in decades ago. So some people see it, there's a lot of improvement in terms of computer, but there's also the fundamentals that practically stay the same, because they kind of like a fundamental principle that doesn't change. So that's why in terms of learning computer matters softwares, we need to balance between what is already progressing, but also we need to see what the fundamentals are still there. So in that way we can balance what we need to learn, because otherwise we going to be very confused with a lot of differences, variation that comes up.
Yeah. Thanks for it. I think that really ties in with our with the rapid expansion and development of computer science and etc. So if you mind, I'll tell a story a bit about me from SMP, from middle school. So in my middle school, I think it's gonna be quite uncommon to you. There's already a coding and computers. Already in part of the curriculum, and every week we have 2 periods that we learn coding, and it doesn't have to start with Python or JavaScript. You can start with Scratch, or maybe MIT App Adventure. So could I what do you think about teaching our new learners and future runners of this country 21st century skills such as coding, and how would they benefit from it, and for the future? Could you please give some insight on that?
I think it is interesting that right now there's a lot of diverse tools that we can use and people have access to. So people don't need to, let's just say, for example, for them to start typing codes and see something on the screen, they don't need to wait long. Like you say, they need to study programming concept for, like you say, 2 semesters before they can start to typing the code.
Don't need anymore.
So that's really a very exciting improvement right now. So people can start doing things and see the results. So that's a good feedback for people to have ongoing motivations. So that needs to be make use of, because that's a really great benefit. But then my advice is to be also, in addition to start doing the coding also in terms of practical level, but we also need to understand the conceptual level behind it. Like, for example, in terms of principle, we need to see fundamental ones like coupling, cohesion. So concept that people need to understand if they want to develop more complex software. Because for a start, you can do with the immediate tooling that you can access to. Like, for example, that you mentioned that now even the tools to start programming even can come from the visual things, even from like games like what you call it, that in from block and stuff. Minecraft. Yeah, even using Minecraft, you can already do the programming.
Redstone.
Like that. Yeah. So Microsoft has tool where you can just fit the block there and give some conditional, some loops there, and basically in terms of a concept that you already do the programming. Even that's kind of a more in a visual style, but that's also already good for a starting point. So you can have more, let's just say, a test first before you get deeper into more conceptual level. So that's really beneficial parts there. But then if you also want to go deeper as a professional, you also need to go deeper in terms of like I mentioned about the concept, how you structure the code that you write. If you want to, you say, if you want to make software that you want to just use this week or for this month and that's it, it will be different way you make software for that you will maintain for years or decades. That's going to be need to be structured differently. So that's what you need to learn after you the code is already running, and the next time how you structure it so it can be maintained for years and stuff. So that's one that's not going to be easy, because you're not going to deal with only code. For large software, even in terms of coding, probably it can be in terms of proportion that you need to focus on, it can be about probably 50%, even less for larger software, because then what you need to deal is people after you have more complex software. Because for more complex software, you need to also deal with other developers, other teams, and that can influence the code that you write a lot. So if you don't structure it well, how you deal with the code and the people, it's not going to scale. So that's why for people that would like to go more deeper in programming, even the suggestion would be not to just focus on the code, but also on how you deal with other people, how you like you say agree with what terms to use, what process to use. That's also part of software development.
Yeah, that stems back to your time period with BBM.
Yeah. Even that's even much more complex in terms of what you need to do for developing software. You not to just write lines of code, but you also need to deal with even issues like time differences, how you deal with different.
Maybe also higher ups who doesn't understand coding but asks you to do something. Yeah, that's something we also experience.
Even you need to deal with other engineers that within the same organization, and also with for large software you might have cases where you need to also outsource some of the work to other developers from other organization. So we need to coordinate with that. So like kind of.
So you can like send your project to them.
Yeah. If you have a larger project, you might have parts that you cannot deal with your own team. So you need to outsource them to other teams, and we need to coordinate with that other teams. So that's gonna be tricky if you just focus on how doing the code all the time, but you also need to pay attention how you deal with other people.
So how is the ending of that combined work together? Like when you finish your project and you send it to them, and then they continue it, and probably they probably send it to the others, and then eventually it will finish, right? And how is the final project? Will it be all together that you and your friends will accept or will receive together, or how is it like when it's final project?
Yeah, so that's why a very interesting thing in software engineering is that you can have feedback quite early. For example, if you deal with civil engineering, let's just say if you want to build a bridge, you build something and you can have the feedback, let's just say 2 years later, 3 years later, where the bridge is being finished. But in software, you can actually see the result of your work quite early in the process. I say, since it's basically just software that if you build, you can already see on the screen, right?
Yeah.
So we leverage a lot of that condition. So, for example, even if we outsource the project to other people, we have a process that's called, in software engineering, there's a process called continuous integrations. So you integrate every work of everybody as soon as possible, even in minutes, hours, days. So if you have code that's already finished by other team, they can just send that changes to the central server, where the central server there will integrate that code with the rest of other codes. So when there's things that doesn't fit, those people will already see the feedback. So we can avoid the issue. Let's just say, for example, some team from other company doing it, and then when we integrate for, let's just say, next month, things are breaking. So we can avoid that kind of thing. So with a continuous integration, everyone can see the result of other people in a short time. So we can already see if some people do their work correctly or not. So that's why it's quite important for the team to prepare the continuous integration infrastructure early in the project. So that's why I mentioned doing the coding is only the first step that you need to do in terms of being a software development professionals, because then after you write the code, you need to deal with how you integrate that with other code from other people, how you need to synchronize your work with what the business side is expecting, what user is expecting. So that's why there's practice that I just mentioned, continuous integration, but there's also a lot of other practices that we need to do also. So this is one practice. Like you say, another is like a test-driven development. So like, for example, if you see the code and you see if it works, when we think about that process, we tend to think that we need to write the code and then test it afterwards, right?
Yeah.
But then in terms of software development that is to be effective, we need to actually write the test first. Because then because there's a lot of uncertainty in terms of how the software being executed, because there's a lot of cognitive load, right, in terms of software that can be quite complex. So it's much more safe if we create the test first and then we write the code afterwards, so we can see whether our code already fit to that requirement continuously. So that's why in terms of professional software engineering, it can be quite different from what you do when you start with, let's just say, software tutorials and stuff. Usually at that stage, people need to focus first on how to write code, but then when you start to write production software being used by other people, by people outside of the company itself, you need to start with how people will be using it. So that's why there's practice like test-driven development, continuous integration on top of the typical coding that we need also to master. So it's still important, but then after that you need to also deal with more stuff with more scope there.
Yeah, I think in my opinion, coding itself could not just be used to just code itself, but I think the process of coding and the mindset you take and how you collaborate with other people could also be used for 21st century learners. Such as the one when you said to test it before you implement it. That can be used for when you're majoring in engineering, that you have to test it first before you actually put it in your in your project. Or I forgot the name, but refactoring. Refactoring. Yeah, when where there's already a complete code that you would rewrite it to a simpler one and a more better one. I think it could also really be applied in students' daily life or when they're learning. Don't you agree with that?
Yeah, true. So the concept of refactoring is that what you already have, if you want to use it for longer time, you might need adjustment to it. So if the structure is not clean, if the structure is messy, you cannot change it, right? So if you want to change it, you need to make sure it is clean first. Otherwise, it won't no longer be called software, because you cannot change it anymore. So that's why people calling it software. There's a soft things on it. So you need to make it stay soft, where you need to be able to change it. So if you don't do the refactoring, the restructuring of the code continuously, there will be some point where you have software that you cannot change anymore. Or even if you change it, you will have risk that you add this feature, but then the software become buggy, it crashes a lot. So that's why we need to keep things well structured if you want to keep growing. It's kind of let's just say in our house, our room. If it's messy, we cannot do anything anymore in that space, right? You need to have it organized if you want to have more things on it.
So that's why we have to put your phone carefully on the table, not bang it on the table, right?
Are you mentioning me?
But no, actually.
You are.
No, I'm actually just explaining.
My phone on my table.
Yeah, because devices have soft particles, soft things, right? Where we have to maintain in order to keep it safe and be more preservable in the future. So you've been doing your job for quite a long time now, right? And what is actually your job description?
Job description. So if in terms of back to a role of being a VP of architecture, so the architecture part is kind of the emphasis there, where you make sure that the interaction between, so in terms of codes, so you have kind of a hierarchy there, right? Like you say, from words you have statements in terms of code. Statement is one line of code where computer executes, and then some line of code is being grouped into, let's just say, one class or one function, and then one function and one class is being grouped into modules, modules can be grouped also in terms of libraries, frameworks. So that's why we need to make sure that things go into correct place. Otherwise, people will have a hard time to find things in that code, how to connect things in that code. And if that's not being structured properly, it can be hard for people to, like I mentioned, is to make the software still being able to be changed. So that's why we need proper architecture for each software, for each specific software. So that's why you don't design the software, even the future the same, but if it's being used by different number of people, different style of usage, or for the phone, for the TV, it can be quite different in terms of architecture. Although in terms of function, you can see that I can see the video here, I can see the video in a TV, but it can be really different that if the video played in the local file in the device itself, or it can be from the server. I just say for like in video we do a lot of live streaming there, so even if you see the picture moving on the screen, what happened beneath this can be quite different if we play what is on the device and what is on the server,
depending on the quality of the maybe connection.
Connection. And you can imagine that there's one video that people, like you say, millions of people watch at the same time. It can be quite different how we design that software compared to what's just being accessed by let's just say 10 to 15 people with that million. So that's where the architecture comes in, because what people don't see is that when he see that video, if it's on the server, it's actually one people will need one line of data from his device to the server. So you can imagine if there's million people accessing the same file, we kind of like need to make a road that have million lines for people can go back and forth. So, but the problem with software is that people don't see that other people accessing the same thing. So sometimes they just, it doesn't work, it buffering and stuff. What he doesn't see is that other people also accessing that same file. So that's why the road, the quote unquote the road that needs to be used for that video goes back and forth need to be really huge. So you say if you want to support that million people seeing same video at the same time, you can imagine how we can make the road with million lines where people can go back and forth. So that's where the technique of software engineering comes in, how you deal with that kind of constraint and requirements. So that's where the software engineering can be quite hard but fun at the same time, because one of the things that we need to do is find the way to trick that situations. Like for example, if you have people accessing the same stuff at the same time, sometimes we can think that you don't need to go to my place, you can just get it from the location near you. So let's just say there's 100 people accessing the data from Bintara, for example. Instead of they go to, let's just say, Jakarta to get it, we just put the stuff on the, let's just say, the nearest mall there on Bintaro, so people can get it from there, instead of going back to Jakarta, going to a toll road and stuff, going to the traffic. So that's kind of a trick that have analog on the physical world that we can translate into the software. So in software we have let's just say concept like caching, where we put the thing the closest to one that needs it. So it's kind of a way that, let's just say, we have people that need the same stuff at the same time and they have the similar location, we just put the stuff there instead of getting back to the original source.
Oh, caching with a C-H-E.
Yeah.
Oh, that. Oh,
Caching.
I thought it was cache.
No, no.
I was
Caching,
confused.
caching is like you put instead of people getting it from the original source.
Yeah, you
put
could have cached it on
on the
some
nearest
device,
place
yeah.
there. Yeah. So instead of we are dealing with let's just say 100 people, giving them one by one, we just put 100 package on the nearest place for them, so they don't need to go directly to us. So they can have a smaller travel time. So let's say to the mall they just need 10 minutes. So that 100 people just need 10 minutes to go to that stuff instead of let's just say go directly to the original source. For example, like that needs to be 1 hour or so. So that can save a lot of time.
Because it's like a waste lot of time. You have to go all the way to
Yeah.
place from there.
Yeah. So that's what actually happen if you do if you watch live streaming. So if you just create millions of roads go directly, there won't be scale, and we cannot actually build that much of roads, right? So we do a lot of tricks there.
But wouldn't that cause delays to the TV, to the one who was the audience watching? Wouldn't that cause a bit more delay?
Yeah, so that's what the trade-off things come in. So in software engineering, there will be trade-off is something that in order you have you want to get something, you need to also give something, right? So you say if you want to have people have fluid access to the stuff itself, you need to sacrifice one aspect. Like for example, that's what I mentioned, the buffering. So it can be that since you need to also put the stuff on the nearest place, you need to have time to put it there, right?
Yeah.
So that's why that can be a certain delay in term of delivering stuff. So we need to see the trade-off between what we want and what the constraint that we have in the actual practical fields.
Yeah, I heard 5G would fix that. Is that true? Lower the bandwidth, lower bandwidth, higher bandwidth, but more smaller wavelength that would reach the TV.
That will help, but only up to a certain point. So it's still we need to do a lot of engineering to make sure that, because even if there's increase in terms of bandwidth, it won't catch up with the need that people need to have the same access to the same source. We still need to do that trick in terms of doing the caching in between stuff. So that's what computer science concept usually comes. They have concept like caching. They also concept like multi-threading stuff. So people, let's just say in terms of visuals, if you have large data that comes to your device, it can make your device stuck, right? Because it needs to wait for data to comes in.
Yeah.
But then that's where the concept like parallel processing, multi-threading comes. You can have other parts of your program can still running, while the other parts still waiting for the data. So that's why if you use the properly written software, even if there's a slow response from the server or from the network, the application itself should not be hang or cannot respond, doesn't not responsive and stuff. So if it's being written properly, even it waits for data, it can still function for other data that doesn't relate to that data that's being waited. So that's where the needs to know not just how to make things work in code, but also how to design and trick the situation where you can still have this, but also have this, but with the smallest cost as possible. So that's require not just the knowledge of the syntax of the language, how things can be running, but also how things can be properly balanced between the trade-off and constraint.
So, yeah, there's a lot of things in like in computer science and information technology. So, since that, the IT field has been taken by a lot of people because of the hype, right? Like everything is technology and information. So, what are the pluses and the minuses of people taking that field? Like a lot of people, some group of people, getting into that one specific field.
Yeah. See?
No, thank you.
There's a lot of good things because then it means what people need from information technology, computer science can be much more easily accessed. People can have things more easy in their life, having the software that is more readily available. Let's just say compare that on the early days where people, I want this software, do this and this, they will need to wait for, you say, months to have that functionalities.
Yeah.
In these days, depends on the what people need from the software. They can probably what needs to be months back then can be probably just hours these days with already existing frameworks, tools. Even the recent development is if you heard that there's on no code software. So
Huh? I'd never heard of
How's
it.
yeah.
I've never heard of
no
it.
code software
Never
is
heard.
like the easiest analog is like Excel. So if you see Excel, it's kind of putting things on cell, right?
Yeah.
But then if you see underneath Excel, they have a programming ecosystem actually
Yeah.
integrated with that software. So you can actually link this cell with this cell and have some calculation on it, some conditional, some loopings on it. Although it's not in terms of you actually write code line by line. So that's what being emulated across other aspect in software. So there's now a lot of software ecosystem that doesn't need actual programming to give the functionalities. So there's development in that part. So it makes the software much more accessible for people, and that's a good thing. And the one thing that we need to be more cautious is more on the how you don't try to make certain software solution that doesn't really fit into the requirement. Like for example, back to the no code example, you can do a lot of stuff on it, but then you cannot force it into something that, let's just say, you need some critical running software, let's just say for rocket ship, for medical situation.
Yeah.
That might not be proper use of it, because that kind of software needs more rigid logic that need to be assessed of, because the risk is someone else's life, right? You need to handcraft the code line by line to make sure that it doesn't contain some risky logic that will fail when it runs. But usually in other situations where you just need the data being calculated, you don't really mind, let's just say it runs for 5 minutes or 10 minutes, as long as I got the results, that will be fine. But then you cannot use it, let's just say, for example, where people need to see someone else's heart rates, and you need to wait for 5 minutes what the heart rates for these people. So even the calculation will come out eventually, but it will be too late at that part. So you need to be aware of the limitation of each framework. So that's why going back to what I mentioned about the fundamental is important. If we know the fundamentals, we can see that this solution can help with these needs and stuff. So we can match what already innovated by people with the right situation, but not to treat the whole thing, the whole problems the same way. So that's what needs to be aware of. So yeah.
So is there any, like, what is the qualification for people to be in a position like yours?
For the qualification is it's kind of natural progression actually for software engineer if they stay on the same field for years, if they pay attention to what they need to grow on, usually from doing the coding, usually then you start to see that it needs more structured design. So in that part we will start to see how we can build software with proper patterns. So not just line by line, but also the pattern, the structure. And from the structure, if you keep at it long enough, also you need to see that between components you need to have various trade-offs, you need to have various communication between components, and relate to that components, you need to also see that people that develop each component need to have also collaboration stuff. So that's kind of what you need to pay attention on and learn on from the day-to-day work itself, or also from the conceptual level, from books, from materials, from courses. So that you need to keep in touch with that materials and what you do day to day. So that's kind of a natural progression that people start to see from the coding line by line to the higher level of the software itself. And like I mentioned, the people side of it. So people tend to have a picture of the best programmer is the one that is sitting on the corner of the room with headset on, and they keep at it 12 hours a day in front of monitors. But that's not what actually software engineer do. The one that's really deal with the real day-to-day case. That's not really what the programmers do. You cannot just sit in your desk and deal with only lines by lines of code. You need to see you need to deal with a lot of things, not just the code still matters, but then that's why you need to pay attention to others, so you can have the proper lines of code that is running on your system. And that means deal with people, even deal with like purchasing. So if you want to have this code right, and you need this machine to build and testing it, then you need to find the specification of that machine, where to get it, because you cannot just throw it to the, let's just say, purchasing department. I want a powerful machine. They cannot purchase that kind of machine. You need to give them specification. You need to give them hint on where to get it. Even the range of price and stuff. So you need to be able to deal with not just your work, but also a lot of aspects surrounding your work also. But also it's to the point that where people can start pick up your pick up their parts when you have done yours. So I just say, for example, from, like I mentioned, the machine specification, but then to the point that people can already start purchasing it, you can start to make the specification, and the purchasing department can do their work doing, let's just say, they find a vendor and get the best prices for that. But then to be able to have those things work, you also need to deal with that part, so with that specification. So you cannot just rely on, I just want to code day in and day out, and doesn't care with anything else.
So the machines is like very specific, right? Like only that one type and not others.
That's for specific case where, I mean, you cannot just focus on the code, but you also need focus to, I mentioned about the people that you deal with your code, with the tools that you need to have for the code to be able to be written and built. So you cannot just I just want to type things. I don't want to deal with. I just want to type things. So that's not actually work in terms of professional software development. Although there's a lot of tools that helps. Like you say, for example, if you want certain machine right now, you can just rent it from the cloud machine.
Yeah.
But even at that situation, you still need to know what the consequences of each specifications. So you also need to know the trade-offs. For example, the remote server will have a very different connectivity issue with the one that's already on your desk, for example.
Oh yeah, of course, because you have to pass your connection bandwidth and everything.
So you need to balance that trade-off. I don't want to deal with physical hardware, but then I also need to know the limitation if I want to use the.
I think it's more to delays, and you have to pay also. Yeah, you don't.
So you need to really know your problem. As you say, for example, oh, my problem is this and this and this. So even if I have delays, they will be okay. So that's what you need. That means you need to talk with people. What is actually being needed for this software that I need to be built? Sometimes that makes a lot of difference between let's just say 1 month project with just 1 day. So that's why the communication is quite important. So you say if you have someone, oh, I want this software can doing this and this, please build it for me. So if you don't have a good communication process there or good communication skill there, you probably just just go to your desk and write those software for a month. But then if you have a better communication process, perhaps you can see that this is probably what he doesn't really, there's some hidden requirement behind what he talks about. So we can discuss things more with him. What is actually you need by this future A, future B? Oh, I need this for this, for this, for this. Oh, for that you don't actually need those future A and B. You can just use X and I can build it in 2 hours.
Yeah.
So that's why the communication is really critical there. So if you just know your syntax of language, you cannot uncover that kind of behind the scene issues that you actually need to be an effective programmer. So in a way, everyone in professional field usually come to the same purpose, that they basically there to solve things, right? To solve problem that their client needs, to solve problem that people needs. So that's what we need to focus on. We do have fun in terms of doing programming. So that's why when we see 1 month project, I can do this in a month, it's going to be fun for me. But we also need to emphasize with other people that when we see that he actually need this more simpler software, that's our responsibility to give that feedback. Although we can lose that, I cannot do this for 1 month, then just 1 day work finish, and I will need to work with other project after this. So we need to balance that needs. So if we find that there's already software that solve this problem, that can be the best solution. We don't even need to work anything. Oh, you don't need the software that I need to write. You can just buy this piece of software that's already working and fit your needs. That can be part of being software professional also. So it's not just writing code, but basically the fundamental work is solve people problem there.
So communications, it matters a lot, right? In any type of job, not only even in IT. So
even in terms of programming, you can see it also in a way it's also a communication work where you communicate with the machine what you intend to do. Just that the language of the machine is much more complicated than
what. Actually, what language of coding do you in video use?
Oh, in video we use a lot. Probably the whole language. Yeah, we have a solution in video ranging from using Java, Kotlin, Ruby, Go, JavaScript, a lot of language that we use there. So that's why the needs to focus on the problem itself, because when people start early in their careers they usually start with certain technology, right? And sometimes that can make what's called tunnel vision, where people see, oh, everything can be solved with this language.
One language. Yeah. It should be, but I don't think that's possible.
Yeah, it can, but then whether that's the best possible solution, that will be another question, right? So if you have more experience in the field, you usually then have more coverage in terms of technology, so you have more tool set in your box, so you can pick better solution based on your tool set. So sometimes this language is good, sometimes this one is better. So that's why you need to keep learning and focus on solving the problem itself.
But what is the importance of using like all of those languages like in one work?
Yeah, each language usually make with specific use case, how it's being used in mind. Like you say, for example, let's just take Java for example. They tend to focus more on portability, and like C++, they focus more on performance. So if you want to have more performance software and it's very critical, and you just need to choose C or C++ there.
It's C#, not C++, I think.
No, for performance, you need to get it directly to the machine language.
No, I mean, you said C++, isn't it supposed to be
no,
pronounced C#?
C#, there's another language. There's a C, C++, C#, even D language there. And
I don't understand about any of those.
Yeah, they're all different. So like in C#, it runs in .NET, but C++ it runs directly to the processor because it's natively compiled to the language itself.
How is the development of information technology related to empowerment and self-quality improvements?
Learning programming language. You mean building characters?
I think it more towards to how learning coding language could possibly affect maybe their ways to learn, maybe, or reasoning or something like that.
There's a lot of effect that people can benefit from learning, even if you don't want to be a professional programmer, right? Because if you learn coding, you will learn how to deconstruct problem into pieces, and then tackle that pieces into more structured solutions.
Like let's say me going to Paris. First, I have to go get a visa, get a passport. That's essentially what coding is. It's just solving a problem with structured instructions.
And you can structure it into the higher level pieces first. I need to get to this first, and then you go to deeper. And that actually what you'll do when you start programming. You start with, like I mentioned, you start with a task. So task-driven development, you start with, that's why in task-driven development, there's also a style of testing that's called outside-in. Outside-in is when you make a test for high-level feature first, and then you make a test for more lower-level parts of the code. So it's like, I want to go to this city. So to this city, you need to go to the A and B, and then you drill down more into how do I get to the A here. So that's why where we we deconstruct the problem into pieces, and the solution can be much more achievable than when we just think on the just one big problem there.
For that, before we close, I would like to maybe summarize. So I'll backtrack a bit. First is refactoring, which basically mean to improve, simplify and obviously improve already existing things.
Yeah.
For a better life. And then and then one is communication is very key, and teamwork.
Yeah, it's very important.
And maybe you could add something to summarize it.
So I think what I got was the IT fields has actually a lot more things that I thought. It has even like you said, programmers not only just do programming things, they also have hobbies as well in order to live their lives. And I think programming itself is quite interesting for people in order to understand what, especially since people now have devices like laptops and phones, they can easily understand from coding, or not only coding actually, from programming, they can understand more about those devices and can even improve their self-quality even to a higher level. Yeah, I think that's it.
Yeah. And also add one more, I think the mindset and the way people do coding, and it could also be used for studying too.
Yeah.
Going to A to B, let's say A to B, you could simplify the instruction into a more detailed one. Because I want to get good grades, so I have to study.
Yeah.
Maybe Mr. Hafiz, you would like to add to the summarization on conclusion of this podcast?
Yeah, I think what you already summarized is quite cover the main thing. So basically, what I also want to emphasize is to keep learning and be interested in what you're working on. So usually from that, it will comes naturally that you want to explore more stuff on it. So if you just see thing as work, it becomes just a burden. But then if you see that it's kind of where your passion is there, you usually just naturally learning stuff there, exploring things, questioning things there. So like I mentioned in the start, that it's not just make things work, not just coding work, but then also what also behind it, the concept inside it, and that what keep things interesting and will motivate you to keep learning there. Yeah.
Okay. So I think that's all for today, everyone. Thank you so much for watching, and hopefully you get something new from this video, from this podcast. And yeah, that's pretty much this video. Hope you guys are having a wonderful day, and we'll see you all in the next time. Goodbye, everyone.
Thank you.
Okay, cut. Yeah. Masih, Pak. Masih.